Okay, today let's look at Hess law. Now, some schools will teach you this way to approach Hess law. They will ask you to calculate using this formula where the clockwise equals to the anti-clockwise. Now, there's a much simpler method. This is the way I teach my students. So for example, if you want to find out delta H1, you just imagine that you are walking from A to B. I want to get from A to B, but I do not know this route. So therefore, I need to take an alternative route, which is this way. Okay. You need to take an alternative route, which is from A to B. Okay, so all you need to do is add up the arrows. If you are in the same direction as the arrow, you will add the enthalpy change. So over here, here is the same direction. So you plus delta H2, same direction, plus delta H3, same direction, plus delta H4. So therefore, you will arrive at this delta H1 equals to delta H2 plus delta H3 plus delta H4 to obtain your answer. Now, how do we make use of this to calculate and create energy cycles? So I'll just do a quick example for you. First of all, given all this information, first write out the equation for all of this combustion. Okay, let's look at the combustion of ethene. It will give you CO2 gas and H2O liquid. 2 CO2 and 2 water. There will be 2, 4, 3. 3 O2 gas. Next, combustion of ethane, C2H6 gas. It give you 2 CO2, but 3 H2O this time round. This will be a total of 7/2 O2 gas. Lastly, hydrogen gas. Okay, half O2 gas. Next, we look at what they want. This is what they want. So this is what you start off with. C2H6 gas, giving you C2H4 gas plus H2 gas. Okay, this is the delta H that they want you to find. So you need to decide, do you wish to start from the left or from the right? Either one is fine. So let's start from the left. If you look at this, C2H6 can be found in this equation over here. So you need to treat it as an entire equation. So C2H6 will give you CO2 and 3H2O liquid. Now, you also require 7/2 O2. So we will balance it by putting this over here. So C2H6 plus 7/2 O2 will give you 2 CO2 and 3 H2O. So previously, the red color equation was balanced, but by adding the 7/2 O2 is no longer balanced. So you need to add this over here as well. Next, let's fill this in. The delta H for this is -1560. Next, if you look at this, C2H4 will require 3 oxygen. So if you take away 3 oxygen, there's half oxygen left. H2 will react with half oxygen to give you H2O. C2H4 will react with 3 oxygen to give you 2 CO2 and 2 H2O. So in total, that will give you the same amount here. So this will be -1411 and -286. So to find the delta H over here, you just need to go this direction. Okay, so the delta H of the reaction will be equals to, over here, follows the same direction. So it's -1560. Okay, and now it goes against this direction. So you minus the value here. So it will be +1411 and +286. If you put all this into the calculator, you get a value of +137 kilojoules per mole. So this is how you solve energy cycles. You just need to balance both sides and make sure that everything is fully balanced. And you will definitely get the correct result. And all you need to do is to have a lot of practice to do well for this type of questions. So this is 1 minute of chemistry. See you the next time.